Okay. Hello and welcome to another live stream. Today we're solving May June 2025 variant 1 2. I think I've already solved all the other variants. This one was left, so let's try to do that right now. Yeah. I will have to grab my calculator. Okay. Okay. So question number one is the diagram shows the graph with equation this. Describe fully the sequence of two transformations. Let's transform the graph of y equals to f of x to the graph of y equals to g of x, making clear the order of transformations. The order in which the transformations may be should be applied. Okay, so from f of x to g of x. I see that horizontally the graph seems to have remained the same. Okay, but there has been a vertical change. For example, this was rising by 1 unit, now this is rising by 2 units, so there's certainly a vertical stretch with a factor of 2. I don't know the order of transformation, but I'm going to first write that vertical stretch factor 2. Okay, and then it also seems to have moved downwards. Okay, what's the best way to figure that out then? Horizontally the curve seems to have remained the same, so I will have to do a bit of trial and error, and I can say that if uh, this now has a y coordinate of -4, this had a y coordinate of 5. So if I stretch it first, that's 2 times 5, that's 10. Okay, and it's going to go right to 10 and then come back down to -4, so that's a translation of -14. Which one is first, which one is later on, I don't know for the sure right now. Translation 0 -14. Let's apply that idea to another point and see if it's valid for other points as well. Let's pick up this point. Okay, so this had the y coordinate 3, so it should get 2 into 3 is 6. Okay, it should come up somewhere here, but then it's translated to -8, which means that it also translated to -14 down. So that means that this should be transformation order 1 and this should be transformation order 2. You will get marks for writing the correct order and the transformations as well. This is May June 2025 variant 1 2. Okay, I think it's there in the title of the video as well. Okay, then it says find the coordinates of the point of intersection of the line with equation this. Okay, so this is just simultaneous equations. I can say that y can be written as -4 minus 2x. So 2x minus 4 minus 2x plus 5 minus 4 minus 2x whole square equals to 24. I think substitution for x would have made it easier, but I've done it already, so I'll just stick to that. Okay, when you open up a bracket that has two negative signs, it always opens up with a square 2ab plus b square. That's going to be 16 plus 2, 4 into 2, 8 is also 16x plus 4x squared. 80, 80x plus 20x squared. Okay, equals to 24. So that's 16x squared, 72x, and 80 minus 20. 16x squared plus 72x plus 56, 0. A is 16, B is 72, C is 56. I put it into quadratic formula, minus b plus minus root of b square minus 4ac over 2a. Okay, let's see what I get. This is a yearly past paper chapter. This is basically just solving simultaneous equations if you're asking me about the topic of this question. This is May, June 2025, variant 1, 2. I'm getting x as minus 1 and minus 7 over 2. So minus 4 plus 2 is minus 2. So the point is minus 1 is 2. And -11 minus 7 over 2, comma 11. Oh no, I made an error somewhere. Minus 4. Minus 7 over 2, comma 3. Okay, the coefficient of x power 7 in the expansion of this is 1280. Find the value of the constant p. So this is a particular term formula. I have to look for a particular term. So NCR, k power n minus r, p power r. So I need x to have a power of 7. So I have x power 7 equals to, what is the power that I have from my formula? It's this and that being multiplied together. So x power 10 minus 2r multiplied by x power 5 minus r. The powers will get added. So that's going to be 15 minus 3r equals to x power 7. So 7 equals to 15 minus 3r. Oops. That should be power r. Or r. Minus r. R. So x power 7 equals to 10 minus 2r plus r. 10 minus r. R is therefore equals to 3. So 7 equals to 10 minus r. R is equals to yeah, I just figured that out. R is 3. So 5c3 px square power 5 minus 3 4 over px power 3. Okay, so that's the term that I'm coming up with. I have p square 5c3 should be 10 from my calculator. And then I should have p power 4 x power 4 and then 64 x cubed and over p cubed. Okay, this is the coefficient of this is 1280, which means that this is 1280 x power 7. Okay, so I am getting 640 p x power 7. X power 7, x power 7 cancels out. 1280 divided by 640 is 2. Oh, this was just p squared. Why am I making these mistakes? So p is 640 divided by 1280 equals to p. P is half. Then question number 4 looks like it's about differentiation of point P is moving along the curve with equation this in such a way that the x-coordinate of P is increasing at a constant rate of 5 units per second, and the rate at which the y-coordinate is changing. So dx over dt is 5. dy over dt is what I'm trying to find, giving your answer in terms of the constant a. So I have to first calculate dy by dx. dy by dx is 3 over 2a x power half minus 12. I write out my chain rule. So that's 3 over 2 ax power half minus 12. dy over dt is what I don't know. Dx over dt is 5. Yeah. So 3 over 2a 9 power half minus 12. 9a over 2 minus 12 dy over dt. Okay, so 45a over 2 minus 60 equals to dy by dt. I cross multiplied the 5. That is what I wanted to find in terms of a. And then says that the curve has a minimum point when x equals to 1 over 4. That means that dy by dx is equals to 0. dy by dx was 3 over 2 ax power half, 3 over 2 ax powered half. 1 over 4 is the value for x. Okay, so calculate 1.5 divided by root 2. Sorry, no, 1.5 divided by 2 is 3 over 4a equals to 12. A equals to 16. That was question number 4. Question number 5 is the equation of the curve is this. State the greatest and least possible values of y. I usually do this on my calculator and I'm going to show it to you the same way. Let's see if I have my calculator here. I think you can see it on my screen now. So I'm going to use the table function and I'm going to say that there's the table. I'm going to write my calculators in degrees because I don't know how to use the calculator for the table function in radians. It gives me very awkward answers in radians when I use it for the table function. Otherwise, I'm going to use it. Okay, let's start at 0 and at 360. And since the step by default is 90, I will divide it by 2 and say that the step is now 45. Okay, so what's the highest value that I see? I can scroll down and see that the highest value that I see is 7. So greatest is 7 and least is -1. Okay, then I have to draw this graph. Let's start drawing this graph. It's at 0 and 7. I'm just going to put in 2, 4, 6, 8. So that's 7. Then at 45, it's at 3. So that's 45. So let's mark it at 3. And then 90, it's at -1. So I'm going to put it at -1. This first one is a little, I've drawn the grid in a very awkward way. I would want to draw a better grid so that my graph looks accurate. So on the exam, you should, actually have a calculator that helps you mark your points. I'm also going to do that. And I'm going to say that 2, 4, 6, 7. 2, 4, 6. Okay, so this was this point, and then somewhere here at 3, 45 and 3, 90 and -1, so that's put here, and then 135 and 3, put here, and there's 3 here at 35. And then it's 7. The graph looks something like this. Okay, and then another round of this. So okay, that is what your graph should look like. Hence, determine the number of solutions with this equation. So I will have to draw this other graph as well. How do I draw this other graph? I first plot its y-intercept, and that's 2 times 0 minus 1. So that's -1. So I know that if I were to draw this graph, it would start off at -1. Okay, so that's where it would start off. Okay, now I can find any other endpoint that I want. I would take a reasonably easier endpoint that I could say that the next value that I'm taking for x is half pi. So that's 2.142. So I'm going to draw it approximately at 2.142. That's approximately here. Those lines should look something like this. Okay, so how many solutions? 1, 2, and 3. Let's check if that's the correct answer. Yes, that's the correct answer. So I've more or less drawn the line correctly. Okay. Okay, question number 6 was the one that was leaked. The diagram shows the curve with equation this and the line that. The line and the curve intersect at the point P, which has a y coordinate of 3. Okay, I don't know the x coordinate, but I can certainly find that. Find the area of the shaded region. Okay, let's find the x coordinate of this point because I'm going to need that for integration. I'm going to say that the curve is going to be integrated from that point. So it's both on the line and the curve. So I think I'm going to put that into the line. 3 equals to 6 minus 3x. 3x equals to 3 should equal 1. Okay, so that's the point 1. So I integrate the curve from 5x plus power 4 minus half from 0 to 1. That's one thing that I have to do. And then I have to integrate the line from whatever this point is. So I will have to find this point as well. So that's 0. And I think that comes out to be 2. That's an integration question. So 1 and 2, x minus 3x. So 9, 5x plus power 4 minus half plus 1 divided by half into 5 plus, I can just do 6 minus 3x squared over 2 minus 3. Okay, and then I have the limits on this, which are 0 and 1, and limits on this, which are 1 and 2. Okay, so 5 over 2, so that's 2 over 5 into 9. Let's apply the limits on this only. And I can take a minus 1 over 6 outside, and then apply the limits on this only. It's 18 over 5, 9 power half, minus 4 power half. Okay, once I've applied the limit 1, and the other time I've applied the limit 0. So 6 minus 6 is 0 power squared, minus 6 minus 3 power squared. Yeah. So 18 over 5, 3 minus 2. That's 3 squared and minus 9. So that's 18 over 5 plus 9 over 6. I think I may have made a calculation. I am fine. 51 over 10 is the correct answer. I can also verify these from a calculator. Okay. Coming to the next question, which is trigonometry. Let's start solving this. Prove the identities. I think it's easier to prove this identity from the left hand side. That's sine theta over cos theta plus 7 divided by sine square theta over cos square theta minus 3. So sine theta plus 7 cos theta over cos theta. I've taken a common denominator. Then sine square theta minus 3 cos square theta over cos square theta. The sine theta plus 7 cos theta. I'm going to change the divide to multiply. Okay, and I need cos square in the denominator, so I'm going to change sine square into 1 minus cos square theta as well. This cancels out with that. I see that this is 7 cos square theta, which means that I have to multiply sine theta and cos theta together, plus 7 cos square theta. And I get 1 minus 4 cos square theta in the denominator. So I've proved to you that this is the identity. I've proved the left hand side equals to the right hand side. Then it says now solve. I'm going to bring back what I did, tan theta plus 7 and tan square theta minus 3. Instead of this, I can write tan theta plus 7 and tan square theta minus 3. So cross multiplying, 4 tan square theta minus 7 tan theta minus 15. Let's break the middle term. Or I can just put it on my calculator and do a quadratic. I think I'm going to break the middle term. In fact, 8 into 4 is 60. The factors of 60 are 5 and 12. Or tan theta is common. I have tan theta minus 3 plus 5, so tan theta minus 3. Tan theta minus 3 and 4 tan theta plus 5. So either tan theta minus 3 equals to 0 or 4 tan theta plus 5 tan theta equals to 3. Tan theta equals minus 5 over 3. Minus 5 over 4. Quadrant 1 and quadrant 3. Quadrant 2 and quadrant 4. Goes to only 0 to 180, so I can ignore the later quadrants. Tan inverse of 3. Tan inverse of 3 is 71.6. And tan inverse of 5 over 4 is 51.3. So quadrant 1 theta equals to 71.6. Quadrant 1, quadrant 2 theta equals to 180 minus this, so 128.7. Okay, those are the correct answers. Move on to question number 8. Says the diagram shows a circle with equation x square plus y square equals to this, and the line y equals to minus 2. This is the line y equals to 2. Okay, the line intersects the curve at the points A and B. The center of the circle is at C. So you first go on and you try to take out the center of the circle. Okay, so this should become x minus 7 whole square and y plus 4 whole square. And you add a 7 square and a 4 square on the other side. So minus 36 plus 49 plus 16 is 29. 9 x minus 7 whole square and y plus 4 whole square. Okay, so I found the coordinates of C, that are 7 and minus 4. 7 and minus 4. For A and B, I know that the y coordinates have to be minus 2. What I'm going to do is I'm just going to take the equation that I made and I'm going to put y as minus 2. X minus 7 whole squared plus 2 squared is 4, so 29. X minus 7 squared is 25. X minus 7 equals to 5 and x minus 7 equals to minus 5. X equals to 12 and x equals to 2. So A should be 2 comma minus 2 and B should be 12 comma minus 2. Okay, I think those should be the correct answers. Okay, find the angle ACB in radians, giving your answer correct to 3 significant figures. ACB. Okay, so this distance is between 2 and 12, I think. So that's 10 units. And this distance should be, since it's from -4 to -2, that should be 2. That should be 5. I can just say that cos theta or tan theta equals to opposite over hypotenuse, opposite over adjacent, and inverse of 5 over 2. And then you double that angle. 68.1985. You multiply it by 2. So ACB should be 136.3972. So ACB should be 86 degrees. If I'm looking at it says in radians. Let's change to radians. How do you change it to radians? You say you divide by 180 and you multiply. That's 2.38. I should have just put it on my calculator in radians. I did degrees earlier because my calculator was 2.38. The chord AB divides the circle into 2 segments and the area of the larger segment. The larger segment is going to be this entire angle and this triangle with it. Okay. This triangle is simple. It has a base. Area of triangle plus area of large sector. Half. Base is 10. Height is 2. Half. R squared. R squared is the radius of the circle. What was the radius of the circle? We didn't explicitly pull it out, but root of 29 should be the radius of the circle. Half R squared. And theta. Theta is the outer angle, so 2 pi minus 2. 8. Okay, 360 minus the answer. So 29 divided by 2 plus 66.6. I am correct on that. Yep, that is the correct answer. Okay, the equation of a curve is such that this, it is given that the curve has a stationary point. Okay, so I will have to integrate first to find dy by dx. This becomes dy by dx. That was minus 24. So how do you integrate? You say that you increase the power, you divide by the new power plus c. It's a stationary point, that should be 0, and x should be minus 2. So 12 over 4. So c should be minus 3. That's dy by dx. 12 x power minus 2 minus 3. It says find the x coordinates of the other stationary point of the curve and determine the nature. So I'm going to equate that to 0. Three, and then you swap. That gives you 12 divided by 3 is 4. It's either 2 or minus 2. And then I have to determine its nature. So I'm going to put it back here. D square y over dx square minus 24 over x power 3. So 2 power 3 minus 4 negative, therefore yeah. Let's just find the equation of the curve. So I have dy by dx. Now you see all of these parts are dependent on what you got in the first go. 12 over x squared minus 3. So I'm going to write 12x power minus 2 minus 3. You increase the power and you divide by the new power. And then I'm going to call it d, another constant. What point did I have? I had the point 19 comma minus 2 comma 19. So 19 minus 2 minus 2. It's minus 12 over 2. Minus 12 over minus 2. 6 plus 6 is 12. D is 7. So y is basically minus 12 over x minus 3x plus 7. That says find the equation of the normal to the curve at the point dy by dx equals to minus 9 over 4. So minus 9 over 4. What was dy by dx? 12 over x squared minus 3. So I'm going to first figure out what x is and then go back and plug it into dy by dx. And, I have dy by dx in fact. So I'm going to just convert it into a normal then. Minus 9 over 4 plus 3. Minus 9 over 4 plus 3. That's 3 over 4 equals to 12 over x squared. 3x squared equals to 48. Square is 16. So x is either 4 or x is minus 4. Normal will have the gradient 4 over 9. So y minus y1. Okay. What point are we talking about? We're talking about the positive point. So I don't have the y coordinate of that point. I'm going to go back to my equation, y equals to minus 12x, and find the y coordinate as well. So y is minus 3 minus 12 plus 7 minus 8. So y plus 8, I have to bring it into a particular form. It says a px plus qy plus r. So 4x minus 18 over 9. 9y plus 72 equals to 4x minus 18. 0 equals to 4x minus 9y minus 16 minus 72 is minus 88. That should be the final answer that you get from this question. Okay. We have two more questions to go. Question number 10. The first, second, and third terms of an arithmetic progression are this respectively. So whenever you have three terms in an arithmetic progression, what you should do is you should come up with an idea for D, that D is basically two subsequent terms subtracted together. So D can be calculated like that, or D can also be calculated like that. Technically, these two should be equal. So k square minus 4k should equal 8k minus k square. That's 2k squared minus 12k. 2k and k minus 6. Either 2k equals to 0, k minus 6 equals to 0, k is therefore 6. What are the terms then? I'm not required to calculate the terms, but I'm just calculating because I want to know that the common difference, like it might be 12. Okay, so k is 6 and k is 0. 0 of course gets discarded. So there's just one answer. Okay, then it says find the sum of the first 20 terms. So the sum of the first 20 terms is 20 over 2, 2a. K, 4k was the first term, so 24 was the first term. I see that the common difference was 12. I plug all of that in to find out a final answer. Should be back. Do 760. Now 20 terms. Part B. The fourth, sixth, and sixth terms of a geometric progression are that AR cubed is 36 and AR power 5 is 6. The common ratio of the progression is positive. Okay, that's term number 4, and that's term number 6. Find the sum to infinity of the progression a over 1 minus r. So I have two equations. I need to find out both r and a from these. I can say a is 36 over r cubed. So 36 over r cubed into r power 5 equals to 6. R squared, so 36 r squared equals to 6. R squared is 1 over 6. And r should then be root of 1 over 6. Okay, I can rationalize that and write that as root 6 over 6, what my calculator is telling me. Okay, a should then be okay, so root 6 over 6 cubed. 36 divided by answer. Messes things up. So this denominator is basically root 6 over 36. 36 into 36 divided by root of 6. I've taken the reciprocal because I moved it up. So it's 36 into 36. 96. So 1296 over root of 6. Okay, sum to infinity is 1296 over root 6 and 1 minus root 6 over 6. So that's going to take a bit of time simplifying. Let's write that fraction over a fraction like this. That's 6 minus root 6 over 6. So 1296. Okay. What form do I want? I want it in the form this. So 1296 into 6 is 6. 6 root 6 minus 6. And I factor out a 6. 1296 root 6 minus 1. Okay, let's verify if that's correct. Yeah, that is the correct answer. Slightly tough in terms of doing sets. Okay. Express this in the form where a, b, c are integers. We've done the completed square form lots of times. X squared plus 2ax plus a squared plus b. So let's do a comparison. 1 is 1, 2a is 4, so a is 2, and 2 equals to a squared plus b. 2 squared plus b. B is minus 2. So x plus 2 whole squared minus 2. So that should be the correct answer. Yeah. Okay, find an expression for f inverse of x. So whenever you want to find the expression of a quadratic, you have to have that in the completed square form. So y plus 2x plus 2 whole squared. Take a root on both sides. So you have to decide whether to do a plus or a minus. Since this is pointing backwards, I'm going to say minus root of x y plus 2, and minus root of y plus 2 minus 2 equals to x. So f inverse of x is basically minus root of x plus 2 minus 2 outside. This is find an expression for gf inverse. So you first find the expression for gf. G of x is minus 4. Gf of x is going to be x plus 2 whole square minus 2. X plus 2 whole square minus 2. So minus x plus 2 whole square plus 2. Okay, so this is a very small difference between the two functions. Okay, then gf inverse is going to be gf of x is going to have the domain of the second function. That's also this, so it has the domain of x is less than or equals to minus 2. So y plus 2, or I can just do x plus 2 whole square equals to minus 2 minus y. Put a root, decide whether I want a plus or a minus. I again want a minus outside. Okay, and then I move this to this side as well. So gf inverse is going to be similar to this, and it's going to be minus root of 2 minus x minus 2. Okay, yeah, that's the end of the exam actually. I think I'm correct. Yep, that brings us to the end of the exam. Thank you for watching. I hope this was productive for all of you.